I'm just gonna start. Yeah. So I'm gonna talk about proofs and and what you can do with proofs if you want to. What is a proof? Open question. I don't really know. Proofs. What are they? Why should you care? I've been studying it for years, and everything's broken. Nothing works. Everything's hard to use. It's hard to learn things. Like, anyone else feel the same way? Yes. Anyone tried to do anything about it? No. Does anyone else like notice that every app is basically broken, like a lot? Okay, it's not just me. I'm not crazy. Yeah, mobile apps are so broken, right? They're all broken, yeah. So yeah, this is, wait, let's go back. So I'm Haskell and Chill on Twitter. Hit me up, get that follow count up. I'm trying to get over 1,000. I don't do Haskell, and I'm not really chill anymore, so it's kind of a misnomer. I'm on GitHub. I'm trying to get, so this talk is mostly about Athena, this is a really cool book. Like, check out this book. Oh yeah. Fundamental proof methods in computer science by Konstantin Arkudos and David Musser. David's retired now. Konstantin works at Bloomberg in New York, and we had coffee, and he ranted to me about some things. It was pretty cool. That's on a slide later, so we can talk about that later. But yeah, Apple is, I just took that photo of the Wall Street Journal today, front page of business section, not really the front page. So it's important, I guess. So yeah, industry and academia, two very different time scales. So I think academia has actually got a lot of the proof stuff figured out. Like, they've done the math. They've done too much of the math. They've like done all the math. Like, good luck. And but they're working on like a decade scale, and industry's working on like a month scale. And so, you know, it's not really working out great. But, you know, I want to bridge the gap. Is it impossible? Dijkstra said it was impossible and that I should stop. Huh? Do we want that? Wait. That's a good question. Huh?
Maybe you don't want to go fast. Is it a good thing to bring?
Those are good questions. So Dijkstra said it was impossible, but last night I was like, well, I'm going to try it anyway, again. So I'm raising money for a math-based education app starting last night. We're going to teach you like linear algebra and statistics and connect you to jobs like data science. I'm a data scientist. I don't even know how to do it. So who's trying to do similar things? This is a quick rundown of the field. We got GeoGebra targeting like high school. Grosvenor basis. Does anyone understand? Yo, I want to talk to you later because those things are hard. Thank you. Educara, they put a web front end over Coq. It's very hard to use, and but use Fitch style deduction trees. So that's cool. Dragonbox, it's for kids. Also Euclidia. They're like little move things around. Oh, you've heard of it?
My daughter loves it.
The what?
My daughter loves it.
Heck yeah. I think massive online, whatever that acronym is, are not good. CMU is doing some amazing work. Frank Fenning is just a beast at logic. I don't understand him. I've met him. He loves squash. And he's in good shape. I don't know. Like, dude, he's just beasting on some logic. And he invents programming languages that like are actually cool and work and stuff. Except the tooling's really bad. So I don't know if you ever heard of like C naught is like proving invariance in C, like a subset of the C language. He did 12, which is just some crazy stuff. Logical framework foundation, something made a logic theory. I don't know, man. Mathematicians are working on it, but they don't care about you in general. This slide is a rant, so if you think it's okay to trick people to make money, that's not proofs. So You can leave. Something about blockchain that I probably shouldn't even say. And you can't just invent programming languages. Like, people are just like inventing languages left and right, and they're not even like thinking about it. Like, it's madness. Okay, Solidity, have you seen that thing? Like, what in the heck was that? And that kid even knows about stuff. Like, or like, there were actual PhDs on that. I don't even understand. Like, what's going on? And like, people don't know who knows who Dana Scott is. Like,
What's here?
is here. Yeah, I know. But wait, who doesn't know who he is?
I didn't know until yesterday.
Well, good. You should Google him. He's really cool. So yeah, don't give up. So I found this book on Hacker News, actually. It was released last year. Just pretty randomly found it. I'm just lucky. No one has ever heard of it. The language just has the worst name possible. But I'm getting Constantine, it's like pulling teeth with this guy. I'm getting him to send me the source code. It's an SVN. He wants to clean it up. I said, don't bother. We'll just hack on it and put it on GitHub. Now GitHub's owned by Microsoft, so people don't want to use GitHub. Whatever. So I read it. I couldn't finish it. It's like 700 pages, but I might finish it later. Yeah, we had a good conversation. I've talked with Evan Brady about learning mathematics using Idris. I thought that was a good idea, and he said, don't do it. This book, Handbook of Practical Logic, and it's funny they call it practical. Like, is there impractical logic? I mean, I think so, actually. Anyway. And automated reasoning shows you how to like build Athena and OCaml by hand, very painfully. It's good to know like how it works behind the scenes, but yeah, I mean, if anybody knows like something better than Athena for like accomplishing this, like a non-tactic based theorem prover thing where you can write things that are readable and understandable. Or if you think Coq is readable and understandable, convince me of that, please, because I'd love to use Coq. Yeah. REPL, I was going to make this a REPL-driven thing, but, like, it's just bad. Like, you can't even hit up. You hit up, it's like, what? You have to do the double semicolon, like, OCaml style. Like, I can't with this stuff. But it has some cool stuff, like, you define data types. You can get, like, free theorems. It's just like ignore the bad syntax, but for all, not, just learn to focus on the logical parts, on the like structure parts, ignore the weird question marks and backticks. So it's definitely on the internet. Like, you go here and you will like learn all about Athena. Like, it's a programming language. Dude is crazy, to be honest. I don't know how they like did all this. Maybe that's why they won't share the code with me. I don't know. But like, it apparently does everything, and I just want to use it for education though, because it is very readable. Like, let's just check out some cool library stuff. Oh yeah, there's the internet. Okay, yeah. So like, I like groups. We get to define like. Oh, say yeah. I go back to my talk. I forgot where it was. I was in a Chrome tab. You can't like shift, go to it. Okay, cool. So yeah. So no one knows anything better, really? No? Okay, cool. So yeah, I want to work on Athena. I think it's like a good idea. Get that on GitHub, contribute to it, make the REPL better. It's low-hanging fruit. So like, what do I want to do? I want to prove runtime of algorithms, cost semantics in the literature. It's pretty hard with type systems, and I haven't really seen a lot of stuff, but maybe you have. So feel free to shout anything out at me at any time. Yeah?
There's a talk by Brian McKenna.
Yes.
Strange Loop.
Yes, I've seen it. Yeah, with Idris. I know that one. Yeah, you can do it in Idris. You can do it in every language. I mean, you do it. It's just not easy. I just want to make it easier. Like, this stuff doesn't have to be that hard. Like, I feel like we're making it harder than it has to be. Now, simplification is hard work. But yeah. So I want correctness and variance, like horse style, logic, preconditions, postconditions. Or I want to be able to do proofs for arbitrary algorithms, like just straight up prove it for all inputs, or do like certified correctness proofs where you return a proof for that given input when you are actually called, which is actually kind of more interesting. This is like disorganized, sorry. But anyway, soundness is kind of better than completeness if you think about it. So don't try to get everything, you know, because you won't. It's impossible. There's like lots of theorems that say you can't. So just try to get like some little things working, you know. So types, logic, sorts, whatever. Don't get caught up in the names. This book uses sorts. They're types, whatever. The concepts are cool. Yeah, universal algebra. Like, I think we're a little too focused on the type theory, like nitpicking, to be honest. Like all this dependent type stuff. You know, I gotta be honest, that lambda cube notation is some of the most confusing things I've ever seen. Like, dude is drawing a underline under omega with a thing. It's like, why are you doing that? Like, what? Like, do you have an opinion on that? No, yeah. Anyway, but like things are slow right now because we're trying to do it all. Like that's what dependent types like. It's really slow about really silly things, and it doesn't have to be that way. Like we can just focus on integers and booleans really, or something like, and just get that working. You know, let's just get something out there. So what is cool about Athena? What like really got me passionate is like substitutions are primitive. Like. If you know like type theory, you know a lot of type checking is based on unification, and unification is based on finding substitutions that unify two terms. Does that make sense to anybody? Yeah? Like take a term S and a term T, and you want to unify them using some substitution theta applied to each term so that you get, I'm calling it ST, whatever. It's unified. It's the same term under substitution. It's like a kind of isomorphism when you wave your hands or whatever. So yeah, you get some data type axioms, and like there's an assumption base in this guy. It's very introspective. But you know, I don't have the REPL memorized. Oh well, oops. And it's like called something. It's just gonna be painful for me to show that. Yeah, oh, for all, like a lot of times you want to prove for all. This gives you the cool little thing called pick any, which gives you an arbitrary instance. That's how you prove for all. Pick any x, just give me one, and I'll manipulate it and prove for all x that way. And exists has a similar construct called pick witness, which is like give me a specific thing by construction or something. You can provide a way for it to construct it. It has a cool by induction construct in the language, and it has chain. A lot of it's built on, what do they call that? Substitution term rewriting. A lot of it's based on term rewriting. You just rewrite things to be equal to each other, and you chain them together. Use the induction lets you do the base case and step. You know, that's always good stuff. So yeah. Leibniz equality and transitive chaining. Dana Scott told me last night that Dijkstra was really into this, and so was David Grease, and that they annoyed him about it a lot. Because he's more a mathematician. He just wants to like do his thing with topology and non-constructive stuff at infinity. And they were like, no, man, let's like do everything by the book like Russell and Whitehead, you know, but like there's a middle ground somewhere, we can find it. If you never heard of Leibniz equality, it's cool. And you use the transitive stuff to just chain it together. There's a long history of this. You got like, maybe you've heard of automath, De Bruin, or whoever worked on that. ACL2, probably not heard of that, because why would you? It's like, oh, okay, yeah, it's a weird Lisp term rewriting thing. Other weird stuff, you should know free algebras, they're pretty cool. Natural deduction, semantic tableau is just fun. I mean, it's just fun to do. You can do it with your kids, like it's fun. So yeah, like, let's have a little chat about this stuff. And certified computation, like, think about that. I already covered this. But soundness greater than completeness is better. Change my mind. Any arguments there? This is a seminar.
Yeah, sounds pretty complete. It's easy thing to say because you can't have an unsound logic system and have useful.
Yeah, I guess. Yeah, you're right. Yeah. I think. I guess what I'm saying isn't quite that. I'm saying what? It's trivial, sure. Okay.
Trivial, I say true.
Yeah, well, I guess I'm more focusing on the certified computation example, whereas like there's a huge difference in the number of lines of code it takes to prove for all possible inputs an arbitrary algorithm versus being inside the algorithm implementation and returning a certified proof at runtime as you compute the results. But you also type check that so you know that it's all going to be tied together nice. Does that make sense? Or should I explain it better? Are you just saying that because does anyone get that? What I'm saying?
Why would you ever not want soundness?
Huh? I don't know. TypeScript? Go ask them. I don't know. I don't know because people don't study things before they design programming languages. I can't tell you, man. I just don't know. Yes?
Even though you want to skip over it, can you at least give us a rundown of what sorts were versus types so we understand?
I think they're the same thing. It sounds like you might know the difference, so you could tell us maybe?
I don't, that's why I'm asking.
Oh, they're
But if you say they come from universal algebra, that implies
did they?
construction.
Yeah, I mean that was kind of my point, was that it doesn't matter, but we can Google it. Sorts, universal algebra, what are they? There's just a placeholder. Varieties, see, I don't even know what I'm talking about. Yeah. I'm sure there's a Wikipedia page about sorts though. There has to be. But it would disambiguate it. Oh, yep. Yeah, good luck. Oh, many sorted logic, that's what it is. Oh, there's a whole spiel on the website about it too. It's they think it's a big deal. This paper sounds important. Extensions of first order logic. I haven't read it, but I want to. It's not many sorted first order logic. So you can quantify things. And there's sorts. There's many of them. Okay. And the code looks nice. Is this readable or am I crazy? Yeah. Cool. Let's get that all zoomed up. It's just, the chain syntax is a little hard, I'll admit. Because going multiple directions, you can go back up the tree. I explained it to Dana Scott and he got it pretty cool. So it's just tying everything together and you flow down to some common subterm. You're trying to prove that many assumptions imply some conclusion. You walk your conclusion around, find some points, walk them together, and then it just it's cool. And that's why there's different pointing arrows. It's a little confusing, I'll be honest.
Why is this better than a tactic system?
Because you're learning it. When you use tactics, you don't know what happens really. I don't know. Have people used tactics and learned things from it? Can you tell me how you do that?
I just use when you use Coq,
Yeah.
I rewrite quantum in another, and as long as it don't use auto way too much, it's still fine. It's still know what to apply, what lemma to use,
Yeah.
and so on. So I wouldn't say it's you don't learn anything. You just have to know. You just don't have to automate too much. You can automate the easy case but rewrite systems is pointless anyway. It's way too annoying.
Yeah, I'll be honest. I don't
Yeah.
understand what calculus of inductive constructions even is.
You don't really need it.
Cool. Okay, so I'm good. So yeah. I feel like I need to, but I don't. So I'm already good. Like, anyway, you like say explicitly which axioms you're using for each step of the chain. And then like you say what term it's rewriting. And I mean, I think he picks some confusing operators. I think it's just better to be like U minus. I mean, unary minus. Okay, great, whatever. Oh, this is the sorts. It's just simple stuff. You're just like, cool, whatever. Quantify, use it. Quantify, use it. You know. You define your axioms. You make theories and modules for some reason, and extend them and open them up, because you got to have that stuff. And I don't know, I've found it very readable. I'm hoping to teach myself linear algebra using this.
Does it have an interactive mode where?
Oh, there's a REPL. I was telling you, the REPL is quite poor. So like, I had this whole plan of like using the REPL, and like, we can do it. It's just really hard. So like, let me give you an example. We all love the option type, right? We know what's up with that. Anyone not know about the option type? Okay, so do you know about like type level functions? Sorry. Okay. So option is just like you have none, you don't got it, or you have something, and then you like have some name for it, some x. So it's just algebraic data type, option. You quantify at the type level over whatever type x is, capital X. You know. Did that help? No, it didn't help. I know. Okay. So, but like, let's just try it out in the REPL, because we're hackers and we love stuff that's code. Option, we're quantifying over S. I called it X, so I'll call it X here. It's like none. He wrote all caps, which makes me think he was angry or something. Or it's some. You know, you can give it a cool little name. It's very verbose on this part for some reason. Cool. Yeah, I think it might work. I already defined it on accident or something. I wish I could hit up and replay that. Let's just call it oaf, maybe, or just oops. What?
There's a program RL wrap, and you can pass it a REPL, and it lets you use arrow keys.
Oh my god, that is amazing. How do I get
I
that?
think it's probably, isn't it built into Unix?
Probably not, no. RL wrap?
Yeah.
Yeah, well let me get that like right now, because that would save me a lot of work. Then I'll just wrap it. I don't even have to work on it. Cool. So that's installing. So anyway, let's call this maybe instead of option, because that's already a type. That's whatever. So data type maybe. You gotta put it in parentheses and stuff. I'm just using S again because I'm getting lost. So we got none or we got some. I'm gonna call it value. I don't know why you would call it option value. Good. Whoa, new data type. Cool. And look, it added a sentence. Free theorems, freely generated theorems. I know Coq does this too. It's great. Coq's great. No, not throwing shade at Coq. I just can't use it to study because it confuses me. That's all I'm saying. Anyway, we can now like see. Where did I put that? Yeah, there's a way to like. Okay, got it. You have to use a string for some reason. Data type, axioms, maybe, and it will show us all the free theorems we got from defining a data type algebraically. And like, those are free theorems. That's free. They're just true.
Can you read them?
Yeah, I can translate them from Athena to math. So what we have going on here. Can everyone see the chalkboard when I write on it?
Yeah.
Yeah? Pretty solid? Okay. We got maybe we did S. I'm gonna call it none or some S, whatever. There's parentheses, I don't really care. Oh yeah, I'm translating it to math, that's right. I don't have to care. I'm just gonna be just math. It's just math. That's equal, whatever. Cool. And this is confusing now. Where I go back to X. That's like of type X or sort X or whatever you want. And then this is like gonna take some type as a function, so you'll get like maybe int, you know, string, bool, etc. It's like maybe is a function at the type level, and then you'll get some X of that type. Yeah, cool stuff. I had some coffee. Yeah, these theorems, yo, what's up? So they're kind of basic stuff. It's just really saying none does not equal to some. Yeah. N does not equal S X. Right? It quantifies something, probably, yeah. It's saying for all Y, whatever we'll call it. Well, I'll call it X, whatever. For all X, none does not equal some. For all X and Y. Yeah, this is like a cool one too. I mean, it's also basic if you think about it, but it's like if S. This is like, you'll see this with successor too, with natural numbers. If that's X equals Sy, that implies that X is equal to Y. And then another cool one, what is this? For all V, it's either equal to none. Okay, yeah, so if V is of type maybe, let's say like for all M, either M equals none, for all M, given that M is of type maybe. M is either equal to none, or, I know this is a little weird actually, but I guess you have to say, yeah, you have to say there exists, or there exists some X because you need it to put it inside the thing, such that, what is it exactly? Oh, V equals, yeah, V equals SX. Cool. Who asked me to translate that? Is that okay?
Yep.
I don't think you can see it.
I once I saw one of them.
Oh, you got the whole thing. Gotcha. Any other questions? How much time do I have? I don't know. Cool. Yeah, if y'all know any venture capitalists in New York, like hook it up. I'll do that elevator pitch. I can do it in like 30 seconds. 30 seconds to freedom, y'all. And if any of y'all live in New York and want to work with me based on this talk, or you have friends that live there, like just put them in touch with me, man. I'm gonna make things happen. We're doing this. Like, yeah, my boss is angry because I'm a data scientist and this isn't work, but he doesn't really know that I'm using it to learn linear algebra. Well, he doesn't really care, to be honest. In math, you assume things and prove things. Athena has assume, you know, of course, you want to assume things. Reverse maths. Who's heard of reverse mathematics? Yeah, I'm about to drop some knowledge. You ready for this? No one's heard of it? No one? Cool. I mean, so it's real. It's like going backwards. That's why they call it reverse. So what if you took what you want to prove and then found the minimal axiom set for that? Would that be cool? I mean, you don't want to have unnecessary axioms, right? It's just confusing. And like, it's real. Like, I'm not just making this stuff up. Reverse mathematics. There's even a popularization book on it these days. John Stillwell. Dude writes a lot of books. Honestly, open question to the audience. Why are math books like 700 pages long, and like, why do they write just so much stuff?
They don't write like 700 pages. Who could have bought any publisher would not going to publish that?
Okay, 500 pages.
Same, right?
400. Okay, whatever. Anyway, this book, someone decided to publish this book. I mean, I think this book is good. It's a computer science book. Computer science and math is very different because we want to like be constructive and do things, and I don't know what mathematicians actually want. I don't know. I just want to make apps that work, and it's hard. So reverse mathematics is real. You can Google it. That's the point. If you trust Wikipedia or whatever. Anyway, that's the part we're actually at. So yeah, this is actually the last slide. And there's some cool Facebook groups and stuff, but I don't like PDFs really. So let's go back to that free theorems. We're gonna use them, I think, to prove. We'll do a short little proof. Yeah. So we got them free theorems. We can make the thing somehow. It's a little hard to make it. What did I call it? Sum. So I think you can just make one of them maybe, if you're lucky. Yeah, sweet. Okay, in Athena there's terms and sentences. They're different. You prove sentences and you manipulate terms. Maybe, I'm not sure. Do they have to be different? Open question for me. Haven't figured it out. Oh, you can just get a none, like straight up, easy. That's just facts. And that's some arbitrary type that it just made up for you. Or sort, whatever, anyway. So, oh yeah, we can make terms, are there sentences? See, it's just all confusing. You got two words for things. I mean, they're different. I'm trying. So like, why do you have to assert the axioms? Oh, we give a reference name. Okay, whatever. I think, oh yeah, no, you're gonna want to do this, yeah. So we're gonna want to give ourselves a quick little reference to the axioms. Data type. Axioms that I pulled up earlier. Why is it using strings? Honestly, that is silly. Cool. Is that good? So some of these statements are, you can't enter them at the REPL, you know, standard programming language REPL stuff. Like, you gotta wrap it in parentheses, maybe.
You're typing maybe, right?
Oh, damn it. Yeah, thanks. Thank you. Yeah, the error messages might be a little rough, but see, once you get stuck in, oh, you can hit the double, okay, there we go. So don't just copy and paste the thing.
RL
I think it downloaded it by now.
Yeah.
So how do I use that?
RL wrap and then.
Thank God. Oh my God, you're saving me. Well, up works. Oh shit. I can go, oh, thank you. Oh, but this is a new Athena, yeah. actually think what is in the book? Is it just option? It should just be built in. There, we got it. We got it. We're just gonna call it option now because that's built in. So for some reason, we're gonna define X, Y, and Z. I think this should be done automatically, maybe because this is silly code to write. The little question mark means it's a variable of some kind, though it's like more of a variable or less of a variable than the ones on the left. Can't really tell you about that. So let's do a proof. Conclude, this is a great name for a lemma. He called it option lemma 1 because he was tired that day. I get tired too sometimes. Yeah. So let's say for all x and y, we're going to prove that. I'm just going to write it out. So let me do a quick room temperature check. Did I do a bad job on this? Roman style voting. Oh, you just leave your hands down. Never mind. There's probably a survey or something. But feel free to ask me anything. We're gonna do this though. So I want to show for all x and y that yeah. And if you have any suggestions for how I can do this talk better, also open to that. So we're going to say x equals some y is going to imply, and maybe we can give this a better, maybe we can come up with a name for this lemma, because I don't think it should be called option lemma 1. That's not appropriate name for anything. It's just not. I'm sorry. So we say x equals some y implies that x is not equal to none. I mean, you can figure it out, but you have to tell the computer like really detailed why this is the case. So it's a for all. So what do you think we're going to use? No, to prove it. I mean, yeah. This is constructive, buddy. We
No, well, that's
pick any. We're gonna use pick any, guys. Come on. That was that. I did that whole slide. Yeah. Remember back in the day when we were like, cool stuff for all is proved with pick any. It makes a lot of sense if you think about it. We're done with the slides, though. Okay. So yeah, we're gonna use pick any once we figure out how to write this properly in the notation. There's no partial credit. You either write the whole thing correct or you get yelled at by the compiler. So I might get lucky and write this correctly, maybe. Yo, honestly, is these he did why is this one capitalized? I really just don't get it. Every other data type in this sucker is oops. Not capitalized, I believe. Let me make a list of one or so. That's probably not the right constructor. Oh, it is, or is it? Data type axioms for list. What are they? List has some cooler free theorems, by the way. That Wadler paper about free theorems. That's what's up. So yeah, they're hard to read, honestly. I would make a pretty printer for this. It probably exports to LaTeX or something. I can't even figure out how to run LaTeX. But I heard I should install Nix, actually. Thanks for reminding me. Anyway, we're going to close this tab. It's distracting me. So, what was my point? Yeah, he didn't capitalize like for list. He put it like lowercase, and for option he put it like all uppercase. Like consistency, it just helps your students learn. Oh yeah, I wanted to rant about education a little bit. I'm very passionate about education, but I don't understand how to do it. Like, like I understand like one-on-one education, but like, have you ever tried to teach a group of people? Like, you don't know them. Who are you even teaching? You like invent some idealized version of who your ideal student is, and then you teach to that student. Does that work? It didn't really work for me. I didn't learn a lot until I was like 29. And I was really sad about that when I realized that I hadn't learned anything. So, yeah, I mean, just, you know, it's just... sometimes all you can do is laugh or cry. Oh, man. But yeah, my whole point is like this stuff should be easier. Like it's just it's cool stuff, and we can make it easy. Need like $5 million and a couple good people. This guy is. He's having fun.
Thank you.
One person.
Sorry.
See, you can only teach to one person. It's like the whole point. He's actually a plant. I planted him. This is all an elaborate joke. I work for George Soros. He's a billionaire. And we're definitely like some left-wing activists in here. Yeah, it's all about the free theorem, so, okay.
So, question.
Yes, sir.
Why Athena? Like, if you were to
Yeah, mostly because it doesn't use tactics, but you can use tactics. It has tactics.
but, like, say, have you looked at ACL2, for example?
Well, yeah, I mentioned it. I've looked at.
I may have missed it.
Have you used it?
Briefly.
Yeah, you gotta install like Racket these days, and then Dracula. I don't even know what that is.
That's a nice environment, but you can use ACL2 plain. It's just common. It's a subset.
I tried to. I tried to.
Yeah, it's pretty.
Yeah, I have the books. Much respect for the ACL2 team. Like they did some good work. They proved some floating point arithmetic stuff for some chipset that had failed and stuff. Intel or AMD. How do you know all that stuff?
Just, prowling around various Caribbean systems.
Yeah, I've looked at a lot. Mizar, Izar, Isabelle. God. Automath. You can't even run Automath anymore, I don't think.
Yeah.
What is that one that Bob Constable worked on?
New Pearl.
New Pearl. I've heard that no one's actually ever run it. I talked to John Sterling in person.
He's making red pearl.
Yeah.
No, but he's working on it. I mean, anyway.
Yeah, great.
Side note. Yeah, whatever. Athena, I've been looking for 3 years. Athena is the most usable thing. I've considered writing my own. I don't know what language I would write it in though, because I hate every programming language. If you have any good languages, suggestions to write things in, I mean, I'm open to it. Scala is not an acceptable answer. Or is Python? OCaml is acceptable. It's very painful. I mean, if I'm gonna write in OCaml, might as well use Haskell though, right? And I don't have to write backticks everywhere.
But is there any course course notes using this textbook?
Oh, great! I should have included that in my slides. Carlos, this guy, thank you Google Chrome History. He is teaching a course using this book, and he has some amazing slides that are way better than my slides. I was supposed to steal some of his slides, but I ran out of time. Oh, it's fundamental proof methods in computer science. Just take a look at it. Check out the index. It's got pretty much everything you would ever want in an index. It's a big book. Yeah.
Is teaching a graduate course?
I'll find this. You know, it's not linked on his homepage for some reason because life is hard. You know. Carlos A. Varela, summer. You know, what are you gonna Google? I don't know. RPI summer. Summer stupid. You can't Google Athena. It's basically useless as a search term. Oh, quick brainstorming session. Any ideas for the renaming the language? Don't really?
Why don't you like Athena?
Because you can't Google it. Like, Athena is an Amazon product. Like, you're already screwed there. Athena is an Apache product. Athena is
Athena language, how do you do that?
Or Athena proof.
language. What comes up? Oh, well, look, Google's figured it out now. Google didn't used to know this, okay? This is new, all right?
Maybe it's because you went there. Maybe try it.
Oh, maybe it's because I went there, yeah. Google's tricky, too. I like learning things. Okay, cool. So I'll go keep the name. Y'all.
Yeah, it's just.
I feel like I tell people it's called Athena, and it's a stupid, like, it's kind of a stupid name. Like, it doesn't tell you anything about it. Well, neither does Haskell or OCaml or... Let's just call the language, like, proofs. Nope, that's a bad idea. Anyway, naming things is one of the most hard problems in computer science, as we all know. Also, cache invalidation, like, run into that, like, every day. Like, just, you're looking at the wrong cache. You gotta wait for the data to propagate. Distributed systems, hard stuff, you know. Oh yeah, these course notes are amazing. But like, it should know RPI at least. Okay, it's gonna be here somewhere. Like, he should have put the name of the book in it or something. But he called the course something. Oh, there we go. Software verification. Oh, if you know the software foundations, apparently someone rewrote parts of it in Athena. Yep. And he's not giving me that SVN access, but he is definitely sending me some weird server code, which I did ask for, which makes sense. There's a dissertation. I mean, if you're really ambitious. I'm not reading it. Oh, these course notes. Yeah, they're really good. So you got software verification, like these slides. Like, I'll put the link on the Gitter. Is there like talk specific? I'll just throw it out there. Like, honestly, if you get anything about that out of this talk, it's just read this guy's slides. They're better than mine. These are good slides here about proofs and stuff.